Hi, this is Dharani Murali and you are watching part 1 of Yes Math series, under which in last video we completed the chapter 1 class 10 NCERT real numbers. In this video we are going to discuss the previous year asked CBSE board questions from real numbers chapter. Before getting into the chapter, let's first get aware of the question paper pattern of 2023 March, which is the latest paper. So the question paper consists totally of 38 questions, which is divided into 5 sections. In section A, it consists of 1 mark. 1 mark questions, totally there are 20 questions, under which 18 questions are of MCQ and 2 questions are of assertion and reason. And section B consists of 5 questions, each of 2 marks, and it is very short answer type questions. And section C consists of 6 questions, each of 3 mark, and it is of short answer type questions. And then comes the section D, which consists 4 questions, each of 5 marks, and it is of long answer type. And the last section, the section E, consists of 3 questions, each of 4 mark, which consist case study type of questions. So the types of questions present in the question paper are MCQ, assertion and reasoning, very short answer type, short answer, long answer, and case study questions. So now also we will discuss the previous year CBSE board questions in this order. Now let's get started with the 1 mark questions, that is MCQ of real numbers chapter. So now in 1 mark MCQ questions from this real numbers, there are almost 3 questions. The first question says that the sum of exponents of prime factors in the prime factorization of 196 is. So they are asking the sum of exponents of prime factors in the prime factorization of 196. So in this question, first we should perform the prime factorization of the number 196. Like 196, it is an even number, so it will be divisible by 2. Again it is an even number. 2 into 49, it will be 98, and 49 is 7 into 7. 7 is a prime number, so here we are stopping this prime factorization. So we can represent 196 as 2 into 7 into 7. Here we have expressed this 196 as product of primes, but here we want the exponential form. So we would write, there are 2 2's and 2 7's. So we will write 2 power 2 into 7 power 2. So what they have asked is sum of exponents of prime factors. Here the prime factors are 2 and 7 and the exponents are these two. They have asked the sum of exponents. So the answer should be 2 plus 2 equal to 4. Option B, 4 is the correct answer. Now coming to the second question, it is asked that the total number of factors of a prime number. A prime number has only 2 factors, that is only 1 and itself. Any number which has the factors 1 and itself are called prime numbers. So we will take the answer to be 2. The third question is asked like find HCF and LCM of 12, 21, 15 respectively. This question actually we have discussed while studying the exercise 1.1 of this chapter, because it is directly the NCERT question. NCERT exercise 1.1, third question, first subdivision. So you can refer to the solution of this from the exercise 1.1 discussion. Now let's move on to 2 mark questions or very short answer type questions. So now in 2 marks, very short answer type questions. First question is, if HCF of 336 and 54 is given to be 6, then find the LCM of the numbers 336 and 54. This question, if you see, this is very relevant to the NCERT exercise 1.1, question number 2, third subdivision. In NCERT, if you see, the numbers 336 and 54 are given, and the question will be given like you should find the HCF and LCM and also verify the condition HCF of the numbers into LCM of the numbers equal to the product of the respective numbers. This condition you will be asked to verify in the NCERT question, but in the board question paper, it is been asked like HCF of the numbers are given and we are asked to find the LCM. So first we will take the condition HCF of A comma B into LCM of A comma B is equal to A into B. This is a well-known condition which we have already discussed. So now we will take the data, like HCF is given as 6. We will take A equal to 336 because we know HCF of A comma B is 6. So A will be 336 and B will be 54. We will substitute these data in the condition which we already know. So 6 into LCM of the required numbers equal to 336 into 54. That is product of the numbers. LCM is equal to 336 into 54 by 6. Here we can cancel out like 6 into 9, 54. So we will get it like 336 into 9, which will be 3024, which is the LCM of the numbers 336 and 54, and this is our required answer. Now coming to the next question, it is asked, explain why the given number 17 into 5 into 11 into 3 into 2 plus 2 into 11 is a composite number. In exercise 1.1 we have discussed similar question, but this is a question with different numbers. Actually the numbers are different, but the procedure which we are going to follow is exactly same. We will represent the given number, we will try to represent the given number as product of its prime factors. If we will be able to do it, then we will say it is a composite number. So let's see it like it is of two parts. If we clearly see there is a plus sign in between. So we can take it like 17 into 5 into 11 into 3 into 2 as the first part plus 2 into 11 as the second part. Now when we carefully see these two parts, 11 and 2 are common in both of them. So we will take this 11 and 2 as a single number, that is 22. So see here, we are taking like 17 into 5 into 3 into 22 plus 22. This is the first part and this one is the second part. Here 22 is common in both of them. So we are taking it out. Inside we will get 17 into 5 into 3 plus 1. When we multiply, we will get it like 22 into 255 plus 1, 22 into 256. As far as the prime factorization of 22 is concerned, we know that 22 is 2 into 11, so we can write it here. For 256, we will perform the prime factorization. So, while performing 256 is a even number, whenever we get a even number, we will just divide it by 2 and we will proceed the prime factorization. 2 into 128, 2 into 64. If we proceed, we will get 8 2's. It's not 2 into 8, it is 2 power 8. So we can write 256 as 2 power 8 as the exponential form of its prime factorization. So here we are representing it as 2 into 11 into 2 power 8, which we can also further simplify and write like 2 power 9 into 11. So here we have represented the given number as product of the prime factors. So it is a composite number. Here we are getting the conclusion that the given number is a composite number. They have asked us to explain and we have completed the required steps. Now let's move on to the third question. The third question says that find a rational number between root 2 and root 3. Of course, the last part of the previous edition book, that is the decimal expansion of irrational numbers, is removed, or it is deleted portion, but still it is related to root 2 and root 3. It is a very general question. So if you want, you can learn this also. I'll just explain it in brief. Root 2, we know the value that it is 1.414, and root 3 we know that it is 1.732. Now to find a rational number, we know that rational number is any number which can be represented in the form of p by q, where the q is not equal to 0, or in other words we can also say that any rational number is a terminating decimal expansion. So a rational number between root 2 and root 3 can be written as 1.5 or 1.6 or any terminating decimal number between 1.414 and 1.732. Now the fourth question, the question reads, two positive integers a and b can be written as a equal to x power 3 y power 2 and b equal to x y power 3, where x and y are prime numbers and we are asked to find the LCM of a and b. So first let us write whatever is given, like a is equal to x cube into y square and b is equal to x into y cube. Since x and y are given as prime numbers, we can write it like a is equal to x into x into x into y into y. We are just expanding this exponential form as a normal product of primes, and we can write b equal to x into y cube as x into y into y into y. It is another thing that LCM of any two numbers, we can say that when written in exponential form, the product of the greatest power of each prime factor is the LCM of the given numbers. This is a standard thing we can use, but once we will see in the conventional method also, so we will find the common factors present in both of them. So this x is common in both a and b, and this y is also common in both a and b, and another y is also common. We know that while taking LCM, whichever factors are common in both the numbers, we will take them only once, and all other factors we will take as it is. So here 1x is common, so this we will take only once. There are two other x's, so there are 3x which we should take in the LCM, so we are taking x cube. And coming to y, there are two pairs of y which are common, so this is one of the pair and this is another pair which is common in both a and b. From this we will take 1y, and from this also we will take 1y. There is another y which is present here, which is not common. So again we are getting 3 y's. So we will write it as y cube. Now we will get the LCM of the given numbers a and b as x cube into y cube. Here we are completing 2 marks of very short answer type questions. Now we will move on to 3 mark question or short answer type question. In 3 mark short answer type question, the first question reads like, the length, breadth and height of a room are 8 meter 50 centimeter, 6 meter 25 centimeter and 4 meter 75 centimeter respectively. Find the length of the longest rod that can measure the dimensions of the room exactly. So we have to find the length of the longest rod that can measure the dimensions of the room. So now the given data is length, breadth and height of the room are given. Like length is 8 meter 50 centimeter. We will convert it into single units, like we will convert meter into centimeter. 8 meter is 800 centimeter. So we can write it like 8 meter 50 centimeter as 850 centimeter. Similarly, B can be written as 625 centimeter and height can be written as 475 centimeter. So these are the dimensions of the room, length, breadth and height. Now the length of the longest rod that can measure these dimensions will be the highest common factor of these three dimensions. So now we will find the HCF of 850, 625 and 475, for which first we will perform the prime factorization. 850 we are, since it is a even number, we will divide by 2, and for 5 ending numbers we will directly divide it by 5. So we are finding the prime factors of 850, 625 and 475 in these steps, and we are noting it down. Now we will find the common factors among the 3. So 2 is not common, 2 is not present in 625 or 475. 5 is common in all these 3. Another 5 is also common here. So these 3 is one set and these 3 is another set. For finding the HCF among the common factors present in all the 3, we will consider it only once. So in this set we will take 1 5, and from the another set we will take another 5. There is no other factors common all the 3 of them. So we will find HCF as 5 into 5, 25. In the beginning itself we have saw that the longest rod length will be equal to the HCF of the dimension. So length of the longest rod would be the HCF, that is 25 centimeter. Now let's move on to the second question. Now coming to the second question of this 3 marks. The question is, write the smallest number which is divisible by both 306 and 657. Since it is asked that the smallest number which is divisible by both of the given numbers, we have to find the LCM of the given numbers. If it was asked otherwise, like the highest number which can divide both of the given numbers, then in that case we will be finding the highest common factor or HCF. Now since it is asked that the smallest number which is divisible by both of these, we are going to find the LCM, for which first we will perform the prime factorization for both of them. 306, it is an even number, so as usual we will proceed with the factor 2. So we will get the factors like 2 into 3 into 3 into 17 for 306, and for 657 we will get 3 into 3 into 73, and we will stop it here because 73 itself is a prime number. So we are taking like 306 is equal to 2 into 3 into 3 into 17, and 657 is 3 into 3 into 73. Now for finding the LCM, let's find the common factors among the 2. 2 is not common here, 3 is common in both of them, another 3 is also common. So this the factor whichever is common in both of them, we will take it only once, and all other factors as it is. So for LCM we will take 2 into 3 into 3 into 17 into 73, and we will get the answer like 22,338, which is the smallest number which is divisible by both of the given numbers. This question actually is very relevant to the NCERT question, exercise 1.1, question number 4. In that question number 4, if you see, we will be given the HCF of these two numbers, 306 and 657, and we will be asked to find the LCM. But here the question is slightly changed, but the procedure which we are doing is almost same. There we will use the condition HCF into LCM is equal to product of the numbers, but here we are performing the prime factorization. Now let's move on to the third question. In third question it is asked, find the LCM and HCF of 3930 and 1800 by prime factorization method. So first we will find the prime factors. 3930, it is by saying it is clearly divisible by 3, so we are proceeding with 3. 3 into 1000, 310, again it is an even number, so I will proceed with 2. 2 into 655. 655 is 5 into 131. 131 is a prime number, so we are stopping it here. Again performing the prime factorization for 1800, we will get the factors like 2 into 2 into 2 into 3 into 3 into 5 into 5. So here we are listing out the prime factors which we have obtained from the prime factorization. First we will find the common factors present in both of them. So here 2 is common in both. There is no other 2 present in 3930, so we are moving on to next prime factor. 3 is common, and again 5 is common. So whichever is common we are going to consider only once among the 2, and all other prime factors we will take as it is for LCM. And coming to the HCF, we will take only the common factors which is present in both of them. So HCF we will take 2 into 3 into 5, which is 30. And for LCM we will take 2 from the common and another 2's which are not common in both of them. So 2 into 2 into 2. Similarly for 3 we will take 3 into 3 and 5 into 5 into 131. So we will get the LCM like 2,35,800. Now here we are completing the 3 marks or short answer type question. Now let's move to the long answer type question. Now coming to the 5 marks or long answer type question, we have 3 questions from the previously asked board questions. The first one is prove that root 2 is irrational number. This is a direct NCERT theorem 1.3, which is a solved theorem given in the textbook. Coming to the second question, this is prove that root 5 is an irrational number. Hence, show that 3 plus 2 root 5 is also an rational number. This is NCERT exercise 1.2, question number 1 and 2. 2 questions are combined and given here. This is prove that root 5 is an irrational number is the first question, and show that 3 plus 2 root 5 is also an irrational number is second question. So now let's move on to the third question. Prove that 2 plus root 3 by 5 is an irrational number given that root 3 is an irrational number. So here it is given that root 3 is irrational and we have to prove 2 plus root 3 by 5 as irrational. Now for these types of questions we will follow the proof by contradiction method, which we are going to use here. So we will proceed like proof by contradiction method. Let us assume 2 plus root 3 by 5 is rational. When we assume this is a rational number, then it can be represented in the form of p by q, where p and q are integers and q not equal to 0. So now we are going to perform some basic steps to isolate root 3 on one side. So first we will take this denominator common for both this number, like 2 by 5 plus root 3 by 5 equal to p by q, and then we will take this number to the other side of the equation, like root 3 by 5 equal to p by q minus 2 by 5. Here we will take LCM. 2 by 5 into q by q, p by q into 5 by 5. So we will get root 3 by 5 equal to 5p minus 2q divided by 5q. And now we can cancel 5, which is common in the denominator of both the sides. So we will get root 3 equal to 5p minus 2q by q. Here you see, we already know 2, 5, p, q. All these numbers are integers. So this combination is rational. If one side of an equation is rational, then the other side must be a rational number. That is what we are giving here. Here 5p minus 2q by q is rational since 2, 5, p, q are all integers. This implies that root 3 is also rational. But in the question it is given that root 3 is irrational number. We already know that. We ourselves know that root 3 is irrational, but here in question also it is specifically given root 3 is an irrational number. So now this is a contradiction which has arisen because of the incorrect assumption which we have made, that is 2 plus root 3 by 5 is a rational number. Since this assumption is incorrect, the result 2 plus root 3 by 5 is irrational will be correct. Thus, we prove the required condition that 2 plus root 3 by 5 is irrational. So here we are completing the discussion of the previous year asked CBSE Board questions of chapter 1 real numbers, and in the next video we will start the chapter 2 discussion polynomials. Do subscribe this channel and click the bell icon so that you don't miss any updates from this channel. So let's meet in the next video. Till then, bye bye.